All right, so this next one is a little bit trickier just based on the wording. All right. A plane leaves JFK International Airport and travels due west at 570 miles per hour. Another plane leaves 20 minutes later and travels 22 degrees west of north at a rate of 585 miles per hour. To the nearest 10 miles, how far apart are they? 40 minutes after the second plane leaves. All right, so first off, think about what our picture would look like. If we have a coordinate plane that represents north, south, east, west. Obviously, the plane that leaves flying westward would represent kind of that horizontal line to the left. But if the second plane leaves and travels west of north, then what we really have is we have a line here representing that this distance is 22 degrees. Okay, so if I kind of zoom in on that, we're assuming all of these would be 90-degree angles. So if we're really traveling 22 degrees west of north, then 90 minus 22 gives me that the angle within the triangle we're going to use has to be 68 degrees. Okay. All right, so we can go ahead and sketch. At least we know semi what our triangle will look like. This is 68 degrees. All right. The second part that's a little tricky comes in with how far they're traveling and at what rate. All right. So if we read back in sentence 2, we know that the second plane leaves 20 minutes later than the first. And the question is, how far apart will they be 40 minutes after the second plane leaves? So plane 1 travels 570 miles per hour for 60 minutes, which would be 1 full hour, because it got a 20-minute head start and we're counting 40 minutes after. So 20 plus 40 would be 60 minutes, which is 1 full hour. So that means it has gone 570 miles. Now, plane 2 travels at a rate of 585 miles per hour, but it only travels for 40 minutes, which is only a portion of a full hour. All right? Specifically, it'd be 4 out of 6, or you could think about that as 2/3. So if we go 585 miles an hour, but we only go 2/3 of an hour, then really plane 2 has only traveled 390 miles. Okay? And we're looking for how far apart they are after that time has passed. So this would be a law of cosines setup. All right, so I'm kind of running out of space down here. But we would say x squared equals 570 squared, 390 squared, minus 2 times both of those values, cosine 68. And then plug all that in. All right, and then take the square root of that. And their distance, it says to the nearest 10 miles. I would just round that to the whole mile. Roughly 557 miles. So between 550 and 560. Okay, one more like this. All right, so for number 5. While traveling on his boat, Matt sees a lighthouse at the edge of a rocky cliff. All right, so here we are in our boat. We see a cliff, and then on top of that we see lighthouse. All right, when he is 1,200 feet from the cliff, the measure of the angle of elevation to the top of the lighthouse, so all the way up, is 35 degrees. if the cliff itself is known to be 500 feet tall, then the question is, how tall is just the lighthouse? All right, think about the triangle as a whole first. So think about if we wanted to find all of this. We would set it up first by doing opposite over adjacent. So that would be the tangent of 35 equals x over 1200. Multiply 1200 and the tangent of 35. And we get 840.2. Then we need to come in and subtract the 500-foot cliff from that and get that the lighthouse is only 340.2 feet. Okay. All right, now for this next part, I'm going to kind of just make the executive decision that we are not going to do area of a regular triangle like that. If you really want to know, I'd be happy to show you, but I think it's easier to just think about it as the second part. All right, so anytime we find the area of a triangle that's not a right triangle, you cannot use 1/2 base times height. So if we have an oblique triangle, your formula for finding area is 1/2 AB sine C. Now, the letters are there mostly just as placeholders. If we look at the example you see here, if we have side little a and side little b and angle C, what you'll notice is that that's a SAS setup, side angle side. Anytime you find area using this formula, it has to look like that, okay? So if you weren't given that angle, or if you didn't have one of those sides, you would have to use law of sines and cosines to find whatever information you need so that you could then fill in that formula, okay? So don't let the letters trip you up so much as just, it has to be side angle side. These obviously represent your sides. This represents the angle that's in the middle of this. Okay? So for this first one, I can tell we do have a side angle side scenario, so we have everything we need to make it work. So we would say 1/2, the two sides you're given are 10 and 7, and then we take the sine of the angle we're given, which is 25. So 1/2 times 10 times 7 times the sine of 25, 14.79, or we could round that up to 14.8. Again, since it's area, we need to have units squared, even if units aren't shown. All right, for this one, still a side, angle in the middle, and our other side, so we're good to go. So 1/2, the two sides we're given are 3 and 4. The angle that's included is 145. So 1/2, 3 times 4 is 12, sine 145. And we get that the area is 3.4 centimeters squared. So now, what we could do if we went back to one like this. All right, if you have all three sides, remember the way you have to think about a side setup. Do you remember yesterday? You have to do law of cosines, and you have to find the biggest angle first. So what we could do is we could come in and say, okay, if 50 is the biggest side, that means C should be the biggest angle. And what we would do is we would first set up the law of cosines backwards so that we could figure out how big that angle is. Okay? If we worked all that out and we found angle C, if we know this angle, then we would have enough to do side angle side, and you could plug in the formula just like we did these bottom two. Okay? So don't worry about doing it the way it says with the semi-perimeter and all that. You can always go back and find one of the angles and then just fill in the same formula you would use if you were given an angle. Okay. All right. Homework wise, I think you guys have homework for today, so I would just use whatever time's left to practice day 4, and then go ahead and start on your study guides if you haven't already.